Hello, Matthews Gatos here. Welcome to this video on point slope form. Before I get into that though, I want to review with you slope intercept form from our last video. So slope intercept form is the equation of a line y equals mx plus b. Now it's called slope intercept form because I substitute in my slope and I substitute in my y-intercept, keeping x and y in general. Let's do an example to review. So I want to determine the slope-intercept equation of a line with a slope of -2. There we are, m equals -2, and passing through this point, -2 and 7. So I need to come up with the y-intercept. I need to come up with b. So I've graphed my point -2, 7, and I'm going to use my slope to see if I can come up with what my y-intercept is. Now, slope is -2, or I could write that as -2 over 1. I like it that way because then I can count rise over run. So you can put any integer over 1. So let's count. So slope is -2 over 1, which means I go down 2 and run to the right 1. Down 2, run to the right 1. So I can see that my y-intercept is actually +3. So if I were to connect the dots there, I can come up with the equation of my line. So here's my line that passes through those points. It doesn't have to be a dotted line. I just chose that because it had arrows on either end. Okay, so there is the line that passes through -2, 7 and has a slope of -2. So once I have my m and b, I can write it as y equals to mx. You don't need to write it as a fraction anymore, plus b, which is 3. Now I want to try to come up with a different form or a different equation of a different form with that information. So this is point slope form. So point slope form means I substitute in a point, x1, y1, and a slope. So the name actually tells you what you're doing. So slope intercept form, you substitute slope and intercept. This is point slope form. So you're going to substitute in a point, substitute in the slope, but still keep x and y in general. So since my point is going to be x1 and y1, I'm going to keep x and y in general. So instead of saying y2, I'm going to keep it in general as y. And instead of saying x2, I'm going to keep it in general for x. So really what I have right now is m equals y minus y1 over x minus x1. Now let's get rid of our fractions. So since I've divided by x minus x1, I'm going to do the inverse, which is multiply by x minus x1. But I need to remember it's an equation, it has balance. What I do to one side, I must do to the other. So on this side here, I really have m times x minus x1 equals 2. On this side, multiplying and dividing by the same number cancels out, and I'm left with y minus y1. This is the point slope form of a line. So let's go back to that example we just did in slope intercept form and come up with the equation in point slope form. So my point that I'm passing through is -2 and 7. So that's x1, y1. The slope that I have is -2. So let's write out our formula that we just did. X minus x1 equals y minus y1. Now let's plug in what we know. So we know that the slope is -2, and I have x minus a -2 equals to y minus 7. So that's really, if I take away a negative, that's 2 negatives make a positive, like adding a 2 equals y minus 7. So that is the point slope form. So what I really want to know is, I know those are two different forms, but are they really the same line? So what I really want to know is the equation that I got in slope intercept form the same as what I got in point slope form? So although they look different, are they equivalent? Well, let's check. I'm going to go to my point slope form. -2 times x plus 2 equals y minus 7. And I'm going to try and rewrite this in slope intercept form to see if they're the same. So I need to get rid of my brackets. To do that, I'm going to apply the distributive property. So -2 times x, -2 times +2 equals y minus 7. So notice in slope-intercept form, the y is by itself. So I want to get y by itself. So the inverse to subtracting 7 would be adding 7, and I do that to both sides. So that's gone. So I have -2x, -4, and 7 is 3 equals to y. And you can see that these are equivalent. So they are the same thing. So since they're the same thing, I know that my point slope form works. Let's try an example. So I want to determine the point slope equation of a line passing through these 2 points, -1, 5 and 3, 0. So I need a point and a slope. Well, I have a point. I need to figure out the slope. So I've done a little graph here, so I'm going to find the slope by counting. You could also use the slope formula to do that as well. So I know it's a negative slope because I'm going left to right, I'm going down. So I'm going down 1, 2, 3, 4, 5. So my slope is down 5. And I'm going to run to the right 1, 2, 3, 4. So I know that it's -5/4. That is my slope. So I want to come up with that equation of the line. So let's just draw the line here. So passing through those points. And then I'm just going to put an arrow to show that that line goes infinitely in both directions. So it goes like that and it goes like that. So I know that my slope is -5/4, and I'm going to pick a point that it passes through. Now it does not matter which point that you pick. To illustrate that, I'm going to do this again with the other equation and just show you that they are in fact the same. So let's do the first point, which is -1 and 5. So my point slope form is m times x minus x1 equals to y minus y1. So we have -5/4 times x minus -1 equals y minus 5. Okay, so I have -5/4 times x, two negatives there make a positive, so it's like adding 1 equals this. Okay, now don't let the fraction deter you. I'm just going to apply distributive property like I did before, because I'm now putting it into slope-intercept form. So -5/4x minus 5/4 equals y minus 5. So I want to get y by itself, so all I do is I just add 5 to both sides. So that's gone. So then what I'm really left with is -5/4x. Now I want to combine those together. So I have -5/4. Let me just do this on the side here. And I'm going to add on 5. Well, instead of 5, I want to say a denominator out of 5, which is 20 out of 4, which is the same as 5. 20 divided by 4 is 5. But now I can just add those to be 15/4. Or you could just do that on your calculator. Oops. Let me try that again. 15/4, not a y. It looks like a y. Okay, 15/4 equals to y. So in point slope form, I have -5/4 times x plus 1 equals to y minus 5. In slope intercept form, I have -5/4x plus 15/4. So this is point slope form, and this is slope intercept form. Okay, so that's one possibility. So what I'm going to do is I'm going to do this equation again, but I'm going to use the other point just to see if I end up with the same equation. Now, the point slope equation will look different. How we will know if they are the same is if I have the same slope intercept form. So let me go over here and we're going to clone it, but this time we're going to do it with a different point. Okay, so I'm just going to repeat that whole process again. Maybe let's keep our slope-intercept form at the end just to see so we can compare. Okay, so this time I'm going to use the point here. So I've already established on the last one that my slope was -5/4, so I don't need to do that again. Let's just do the equation with the second point. So I have m times x minus x1 equals y minus y1. So -5/4 x minus x1, which is 3, equals y minus 0. So distributive property, -5/4 times x, -5/4 times 3 is positive 15/4 equals y, because y take away 0 is just 0. So you can see I have a match. So that means that I can have it in point slope form as -5/4 x minus 3 equals y. That's point slope form. that would be correct. And this one that I got before would also be correct. So it does not matter which point you use. Now that being said, I think using this point here would be a lot easier. So anytime the x or the y value would be 0, I would choose that as my point for point slope form because it makes it a lot easier. Okay, let's try another one. So determine the point slope equation of a line passing through this point. So we just have one point, so that's x1, y1, and parallel to this line, y equals negative 3/5 x minus 7. Okay, so that's interesting. So we have to remember parallel lines. Now remember, parallel lines are lines that run in the same direction, and they are equal distance apart. So same direction, equal distance apart. Two lines are parallel if their slopes are equal. So if the slope of one line is equal to the slope of another line, then I can say that line 1 is parallel to line 2. So here's the slope of the line, negative 3/5. So a line parallel to it would have the same slope. So this is really just telling you that the slope is negative 3/5, and a point that it passes through is negative 1 and 5. So let's use our formula. So m times x minus x1 equals y minus y1. So negative 3/5 x minus negative 1 equals y minus 5. So I would have negative 3/5 x plus 1 equals to y minus 5. And I will leave it like that. That is point slope form. Okay, so to wrap this up, the important part about both of these methods is, in fact, the slope. And it was at this moment on the ski hill that Teo wished he had paid more attention in math class. Which run do I take? Well, it's all based on slope, so you decide. What ski run would you take? So I hope this video helped. If it did, please give it a thumbs up so I can reach and help more mathies just like you. Thanks, and I'll see you for the next one.